So today I'm talking about question number 6-9. Write all the KF reactions for the copper to ammonia system. The first thing we need to understand before doing this problem is the copper and ammonia as a Lewis base and a Lewis acid. Copper plus 2 is in an ionized form, so it has 2 less electrons than as normal copper metal. It's called a Lewis acid because it will share a pair of electrons donated by a Lewis base. Ammonium, in this case, acts as a Lewis base because it has these 2 electrons right here that it's willing to share. And again, so these two together are considered a Lewis base and a Lewis acid because ammonium will share the 2 electrons with copper 2+. The next is the formation of the copper ammonium compound. Copper has 4 bonding sites available for ammonium. They'll go like this, so you'll have 1 here, 1 here, one in this position, and 1 here. In each spot, copper and ammonium are sharing electrons. The thing that the reaction considers is, after each bonding of the ammonium to the copper, you have a formation constant. So, if we go to this, we first reaction of copper 2 plus ammonium. So you have copper 2 plus ion plus ammonium, the Lewis acid, and Lewis base. Are going to combine to form copper ammonium 1. And because copper and ammonium have such a strong affinity for each other, you have a compound formation which is listed as B1 as standard value, or beta, and beta 1 is the same as the K, which is formation constant. The K in this section equals 10 to the 9, or 10 to the 3.99, and that's going to equal your solubility, your KSP equation, which is, as always, product copper ammonium over concentration of copper times the concentration of ammonium ion, or concentration of copper ion times the concentration of ammonium. The next step is we have a copper ammonium ion, so in the solution you already have your copper ammonium 1, and then copper ammonium 1 is going to bind to another ammonium, like in the diagram it would be going to, next step would be going to this one. So we now have formed a copper ammonium 2 with another beta, so with beta 2 and K2. The beta here is higher because you're adding another ammonium, so 10 to the 7.33, and again you have your KSP, which is, or your KSP equation, which is the copper, which is a product, which is the copper ammonium 2 over the copper ammonium times the ammonium. Your third step, adding the third copper, or adding the third ammonium, which would be this one right here, will, since you already have the copper ammonium 2 in the solution, your third ammonium is going to bind to this and produce copper ammonium 3 with the third beta, again higher because you're adding a third one, and it's equal to 10.06, or 10 to the 10.06, and same as before, products over reactants. That's what equal sign is here. products or reactants, copper ammonium 3 over copper ammonium 2 times ammonium. Your fourth and final formation or binding of the ammonium to the copper will be this right here. And of course we have our fourth equation, which equals copper ammonium 3 2 plus ammonium leads to copper ammonium 4, or copper 2 ammonium, which is what we're writing the system for. You have a beta 4 equaling a K4 like all the other ones, and then this one equals 10 to the 12.03 because again you're adding the fourth one is higher. Your solubility is the copper 2 ammonium over copper ammonium 3 2 plus times NH3. Now to find the KSP for the overall reaction, we multiply, if you're going by values, all the beta values together, but we're more concerned about the actual equation. So multiplying all these together, this copper ammonium 1 would cancel out with this one right here. Your NH, or your copper ammonium 2 is going to cancel out with copper ammonium 2 here. Your copper ammonium 3 is going to cancel out with the copper ammonium 3 on the bottom of this one. And then your only things left are your 1 copper ion concentration here, and then your NH3 ion in each one of the 4. So then this is going to be NH3 to the 4th. And your final product, which is the copper to ammonium. This final solution, or final equation, is going to look like Cu, copper, 2 plus your 4 ammonium ions, leading to copper ammonium, or copper to ammonium 4 2 plus with your Kf, the overall K of formation, or formation product, equaling to what we figured out before, your product, which is copper to ammonium, over your copper ion multiplied by your ammonium ion to the 4th power.